right, hello everyone. So we have a differential equations question here. We have a application problem. It's a mixture problem, specific. So you have a solution of water and salt flows into a tank. Solution comes into the tank at a rate of 5 gallons per minute, with every gallon containing 2 pounds of salt. At the same time, solution leaves the tank at 4 gallons per minute. Initially, the tank holds 500 gallons of fresh water. Find a differential equation model is what part A is asking, and then part B is asking find the amount of salt at any time t, and part C is find the amount of salt when t is 45. So this will be a two-part video just because there's a lot to cover. So I'll go ahead and work on part A right now, and then we'll work on part B and C in the next video. So let's go ahead and just quickly look at the picture here. So we have a tank, and it's got 500 pounds of just fresh water, no salt in it. And you've got basically a mixture of salt and water coming in, and at the same time it's coming out. And the tank there's in black, the water in blue, and the red drawings there are basically just indicating the two pipes that are bringing the water in, the water out. And yeah, the actual shape of the tank is really irrelevant, but just picking up. Most tanks are like a cylinder like that, so it just that's why I drew it that way. Anyways, so first of all, let's start. Let me call y of t. I'm going to start with a function. Let y of t be the amount of salt in the tank, and that's going to be in terms of pounds. Okay. Now, you can actually find the amount of salt going into the tank and technically the amount of salt coming out. So the rate of change of salt dy dt is equal to rate in minus rate out, okay? And that is a mainstay fixture here for these mixture problems. It's like rate in minus rate out, okay? And let me just go over real quickly the information that we're gonna use here. So we know that 5 gallons of water of this mixture, are coming in per minute, not water again, mixture. And then every gallon has 2 pounds per gallon of salt per gallon in it. And out, we know that 4 gallons per minute are out, and I just wrote here that 500 gallons of fresh water in there. So that's all the information that we need to actually figure this out. So first thing I'm going to start off with is rate in. Okay, so rate in, and yeah, basically what I'm saying is the amount of salt that comes in total. And I'm just going to use dimensional analysis here. We know that 5 gallons per minute come in, and if you times it by 2 pounds per gallon, notice how my gallons units cancel out. You just have pounds per minute, and it's 10 pounds per minute here. Okay, and yeah, everyone's got their own way of doing that part that I just worked with in terms of working with an amount of things going in. In this case, I use dimensional analysis, but some people kind of just reason it out. And they say, well, if you got 5 gallons coming in every minute, and every gallon's got 2 pounds of it, then 5 gallons times each of those gallons has 2 pounds. 5 times 2, 10. Okay, 10 pounds per minute. Now for the rate out, we have that it's 4 gallons per minute. And here's the issue is that I don't know how much pounds per gallon of salt is leaving the tank. We don't know that. However, what we do know is this. I know that there are y pounds of salt. Yeah, y is the quantity of pounds of salt in the tank. And what I know with that is I can make a concentration. I have y at any moment. I have y pounds of salt divided by some number of gallons of water in the tank. And how much is that number of gallons? Well, this amount is changing, because if you've got 5 gallons coming in and then 4 gallons coming out, what does that mean? That means that you have 1 gallon that's left over every minute. So if you started with 500 gallons of fresh water, all right, a minute goes by, you now have 501 gallons of now mixture here, because yeah, now you have salt in there. But what I'm trying to get at here is told you have 500 plus T gallons of liquid in there, okay? And if you multiply again by cancellation, cross cancellation of units, you have pounds per minute, or in this case it'd be 4y over 500 plus T pounds per minute. That would be your rate out, okay? And we're always looking to do that when you're working with these mixture problems. When you get to the part when you're working with the rate out, you're not really told. I've never seen a problem where you're told, I'm not saying that this can't happen, but you're never told the amount, or the rate out, that's the amount of pounds per gallon that are coming out at the tank. It's always a mixture that you have to work with pretty much here. So that's why that's the typical setup is what we do for that part. It's the Y pounds, or whatever we're calling the variable, of total amount of salt divided by the gallons, and you get pounds per minute here. Now, so if you went ahead and you formed your equation, you have dy dt equals 10 minus 4y over 500 plus t. Okay, that is your differential equation. But one thing that's really important that we're going to need is this. You need an initial condition with these. At the very beginning, you were told that you had 500 pounds of fresh salt. What does that mean about the amount of salt that you have? In the very beginning, it means that you had no salt at time 0. Again, no time zero, because you had 500 pounds of, or 500 gallons, I'm sorry, of fresh water here. So with these equations, you need that initial condition. You're eventually going to need it. All right, so that's the end for part 1. Part 2 will answer the 2 other questions here, and we'll see you then. Thank you.